Okay, another problem. A rocket travels upward at 75 meters per second. When it is 40 meters from the ground, the engine fails. Determine the maximum height reached by the rocket and its speed just before it hits the ground. So here, um, how do you think we can solve this problem? When the engine fails, this means what? The engine fails.
Stops accelerating and starts decelerating.
Yes. So it's moving only under the effect of what when the engine fails?
Gravity.
Gravity.
Gravity, exactly. So when you have only motion under the effect of gravity, what will be your acceleration?
G.
G. Okay. Why? If you forgot why, you can derive it again. So if I just have the weight acting on my particle, then if I write Newton law, sum of forces equals to ma, since the only force acting is the weight, then I can say that W, which is mg, is equal to ma, and then m will be simplified, so I can write that a is equal to g. Okay, so I simplify it, and a is equal to g. Then in this case, I can say that it's a constant acceleration. Okay, so if I take y positive upward, here they consider the coordinate s. Since s is positive upward, then I can say that a is minus g because g is downward. Okay, and since it's a constant, I can apply all the relations we developed together. So it's a particular projectile motion if you want, but with an angle of 90 degrees. We will see that in projectile motion, we define the angle between the horizontal and the velocity as alpha. Here, alpha is 90 degrees. Okay? So now, our purpose is to find the maximum height reached by the rocket and its speed just before it hits the ground. So for the first step, how to find the maximum height reached by the rocket? What will happen at maximum height?
Velocity and
Velocity.
acceleration equals zero.
Very good. So the condition that you know is that at maximum height, zero velocity. And at the initial position, you know the velocity. So what do you suggest? How to find the maximum height? Which formula will be straightforward to use? Do you have anything about time here?
V0.
V equal à V0 plus 8, yeah?
No, look, you can do this, okay? But you will need to do two steps. If you write V equal to V0 AT, then you put V equal to 0, you get the time, okay? And then you should replace the time in the equation of S. So you will replace T in S equals to half AT squared plus V0T plus S0. Okay, it's right. But instead of doing two steps, you can do it in one step. You will use the relation that is independent of time. Because do you have here time? No, you should calculate it if you want to use the other method. So please always try to look at the method that will take the less amount of time, which is here using the relation independent of time. What is the relation independent of time? V square final, or here I am applying between points A and B. So between point A and B, I can write that VB square, which is 0, minus VA square, which is given, VA is 75, equals to 2A, A is minus G, so minus 10. So minus 2 times 10 minus 20 times delta S. Delta S is S of B minus S of A. S of A is known to be 40. So then the only unknown here will be SB, and you can directly get SB from this relation. Okay? So here, instead of doing two equations, you will get it from just one equation. Okay? And then they ask you what will be the speed just before it hits the ground. So when it will reach the maximum height, v is 0, the velocity will change in sense. It was upward, now it will be downward. And how to calculate what will be the velocity at c? What should we do? What do you know at c? At c you know the position. You know that s of c is 0. Okay? But your unknown now is the velocity. يعني بعكس البي. بالبي كنا بنعرف الvelocity وبدنا نجيب ال s of b. At c we know that s of c is 0 but we don't know vc. يعني we can use still the same relation and we can apply it or between a and c or between a and b لأنه all points belongs to the same trajectory for which a is constant اللي هي minus g. So what I advise you to do here is to apply between a and c لأنه إذا عاملين calculation error bb to not have an error also in c. Okay, so always try to use, if possible of course, the initial values given. And now you can apply between a and c, but here your equation vc square, which is unknown, minus va square, va is 75, equals to minus 20 times s of c, you know it now, it's 0, minus 40. So the only unknown will be velocity of c, and you get it. Okay, so we can see together in summary the solution. So as we said, first we apply between a and b the relation. The only unknown will be s of b, we get it. And also the same between the other case in they selected to do between b and c. It's also right. Okay, and you can do it between a and c. Both should give you the same result. And you will expect to get a negative value of VC. Why? Because, so here, balance square. So because you are moving downward, okay, and S is positive upward. This is why you got a negative result. Any question on this? Another problem. A metallic particle travels downwards through a fluid that extends from plate A and plate B under the influence of a magnetic field. If the particle is released from rest at midpoint C, where S is equal to 100 millimeter, and the acceleration is given by A equals to 4S, where S is in meters, determine velocity when the particle will reach plate B and the time needed to go from C to B. So here we have in this problem the acceleration given function of position. And the initial position is at C, so the initial conditions are that at t equal to 0, okay, we have that S of c is 0.1 meters. Guys, please pay attention for units. Here, A is equal to 4S in meter per second square. So I will use S in meter in my relations. So convert from millimeter to meter. So SC is 0.1. And I want to find what is the time needed to go from C to B. Okay, so I know that SB is 0.2. The first question is to calculate the velocity when I reach B, and then to calculate the time needed to reach B. So first, I have a function of S, and I want to find velocity. So I will use the relation between A, V, and S, which is A ds equals to V dV. So this is the first step, okay? And once I find, and here also, why it's interesting to find the equation, because I will need after the time. So I will need to get the velocity equation function of S. And once I get velocity equation function of S, I will use the concept that V is ds by dt, since I want to relate to time, okay? So as a first step, I will replace in VdV equals AdS, I will replace A by 4S. Then I will perform my integration between, for velocity it's starting from rest, so from 0 to V, while for S it's starting from point C, so from 0.1 to S. When performing my integration, I will get that integral of 4S is 2S squared, and then I can get the value of velocity as 2 radical of S squared minus 0.01. So now I have the velocity function of position. Then, since I am interested what is the velocity at point B, I can replace S by 0.2 meters to get the velocity. Now, the next step, because I want to get the time needed to reach B, then I should find the relation between V and T. So I should write here, or S and T. So I know that V is ds by dt. And since I got S function, V function of S, then I can do separation of variables here, since the two variables will be S and T. Okay. So now, once I write this, and by separating my variables, I know that ds is V dt. So since I have V function of S, I will take the function to the side of S. So I get that integral from 0.1 to S of ds over this function equal to integral between 0 and t of 2 dt. Now here, هيدي integration you are not responsible of, okay? لأنه you need mathematical tools, but I will not give you such integrations. Anyway, you can use your calculator, because here I just need the final value. ما بقى عايز الfunction here. So you can directly say I integrate from 0.1 to 0.2, and your calculator can give you the value. Okay, but anyway, I will not give you integrations that you don't know to do. Okay, so here, all I have to do then, once I find S function of time, I can replace S by 0.2 to get the time needed to reach B. Okay. Any question on this part? Please, if you have any problem, tell me. So mainly, this is the first part in this chapter. Okay. Next time we will do a problem to see the difference between average velocity and speed together. Then we will start curvilinear motion. Okay. So see you next time.